All right, now that you've been practicing factoring quadratics, let's make it a little more complicated. As a reminder, when we were factoring something like x squared minus 13x plus 36, how we did it was set up our two binomials, start with this x squared, and we're going to break that into its two factors of x and x. Then we look to the 36, and think about all the factors of 36. That'd be 1 and 36, 2 and 18, 4 times 9, 6 times 6. And what we're looking for is a way to make this 13, this actual negative 13, using one of these pairs. And as you scan through the list, looking at 4 and 9, well, 9 plus 4 makes 13. So that would mean minus 4 times minus 9 would make that negative 13. And of course, we could always check just by multiplying it all out. If we were to FOIL this, firsts would give us x squared, outsides would give us negative 9x, insides minus 4x, and lasts would be plus 36. Combining the stuff in the middle, we get x squared minus 13x plus 36, which is what we started with. So we know that the factored form is x minus 4 times x minus 9. Now let's try and do that when we have a leading coefficient. Now first of all, what is a leading coefficient? And that's going to be the coefficient or the number that's multiplied by the variable. But it's the coefficient of the term with the largest power. So when we're talking about a quadratic, we look for that x squared term, and the leading coefficient that I'm talking about is that 3. Now in general, we're going to start off with our same plan of attack. We're going to set up our two binomials and try factoring our first term as well as our last term. Now when we didn't have this leading coefficient, we knew that x squared was going to break up into x times x. When we have 3x squared, we are still going to have an x and another x. However, x times x doesn't make 3x squared. So we have to look at the factors of 3, which are 1 and 3. And we're doing this in the same way that we did it with that 5, looking at 1 and 5. Luckily, we don't have a lot of options that we have to try, but when I break up that 3x squared into the 1 and 3, that means I'm going to have 1x times 3x. Then I have to use my 1 and 5. Now, obviously, 1 and 5 are not going to make that minus 2 that's in the middle. But what we have to do is really just guess and check. We're going to take that 1 and that 5 and put them in. That's our guess, is that our answer is going to be 1x plus or minus 1 times 3x plus or minus 5. Now we have to check to see if we're going to be right. To do that, all we have to do is FOIL it out. And we know that the way we made this, when we do first 1x times 3x, that's going to be the 3x squared. When we do outsides, 1x times 5, that's going to give us 5x. Now, we don't know if that's a plus or a minus yet. When we do the insides, right here, 1 times 3x, that's going to be 3x. And we don't know if that's a plus or a minus either. And then when we do lasts, 1 times 5, that's going to be 5. And we do know that we want that to be a minus. So when we simplify, we have 3x squared at the beginning, minus 5 at the end. And what we're wondering is, can I make this negative 2x for the middle? Well, when I'm looking at 5x and 3x, yes, we can. We start with negative 5x and add 3x. Then that will give us the minus 2x that we need in the middle. So in order to do that, I noticed that we need this minus 5x. So when I look at where the 5x came from, that was doing the outsides. How am I going to make that a negative 5x? Well, if I have a minus 5 right there. And when it comes to the 3x, that came from doing the insides. I need that to be positive, so I'm going to use a plus right there. Now we have our entire product. X plus 1 times 3x minus 5. Let's try another one like that. 5x squared plus 12x plus 7. All right, we're going to set it up by having our two sets of parentheses. And we need to break up 5x squared. So we think about the factors of 5. That's going to be 1 and 5. Those are my only options. So in my sets of parentheses, I'm going to have 1x and 5x. Then I look to the last number, that's 7. My only factors of 7 are 1 and 7. Obviously, 1 plus 7 doesn't make 12, but it doesn't mean that we can't factor this. Right? What we need to do is guess and test. So we plug in the 1 and the 7, and then check. Now, we don't need to spell things out the way I did in the last example, because the only thing that's important to us is the outsides and the insides. The way that we came up with these numbers, we know that we'll have 5x squared to start our quadratic, and we know we'll have 7 to end our quadratic. But it's all about getting that 12 in the middle. So we look at the product we get when we do the outsides. X times 7, that's 7x. And 1 times 5, that's 5x. Can we make a 12 using 5 and 7? Well, yes. We need this to be a positive 12, so we're going to need plus 7 and plus 5. That will make the plus 12 that we need. So our actual solution, when it's all cleaned up and looking pretty, is x plus 1 and 5x plus 7. Let's try a couple more. 5x squared plus 19x plus 12. We're going to set up our binomials. Think about the factors of 5x squared. Well, our only factors for 5 are 1 and 5. So that means I'm going to have x and 5x. Then we have to think of our factors for 12. Well, 12 has a lot more factors. It's not prime. So we get 1 and 12, or 2 and 6, or 3 and 4. And we want to make 19 out of it. So we have to guess and check. So I'm going to start guessing right at the top with that 1 and 12. Put 1 here and 12 here. Then we're going to check by looking at the outsides and the insides. The outside product, x times 12, is 12x. The inside product, 1 times 5x, is 5x. And the question is, can I put those two together to make 19x? Well, 12 plus 5, that makes 17, and that's about as close as I can get. So what do I do now? Does that mean 1 and 12 doesn't work? Not necessarily. What you should do before tossing out 1 and 12 is switch their order around. So we'll put 12 here and 1 over here. Then what does that do to our two products? Well, on the outsides, x times 1 is 1x. And on the insides, 12 times 5, that's going to make 60x. And there's no way I'm making 19 out of a 60 and a 1. So now we know that 1 and 12 doesn't work. So let's just move on down the list. We'll go with 2 and with 6, and then check them. On the outsides, x times 6 is 6x. On the insides, 2 times 5 is 10x. 10 and 6, is that going to make 19? No. So we switch them around. Go with 6 and 2, and check them again. On the outsides, x times 2, 2x. On the insides, 6 times 5, 30x. There's no way that's making a 19. So now we know that 2 and 6 don't work. It's got to be down to 3 and 4 now. So just going to plug them in. 3 and 4. On the outsides, we get 4x. On the insides, 3 times 5, that's 15x. Can we make 19 out of 15 and 4? Yes, we can. So we got the right numbers. Now we just got to put our signs in correctly. We're trying to get a plus 19. So that means we would need a positive 15 and a positive 4. That would make it 19. So there is our solution. X plus 3 times 5x plus 4. Now this is about as tricky as I'm going to make it for you when we have 6x squared minus 5x minus 4. When we set it up, we get our parentheses ready, and we're going to start looking at factors at the beginning and at the end. And what makes this one so tricky is 6 is not prime, so we get 1 and 6 or 2 and 3. On the other end, 4 is not prime either. We get 1 and 4 or 2 and 2. And now you just got to start guessing and checking. Start putting in some pairs. With the 6, we can go through 1x and 6x. And then start checking the other side. So go with 1 and 4, put those in here, and check the outside and the inside. On the outside, looks like we got 4x. On the inside, 6x. Is that going to make negative 5x? It's not. So switch them around. Change it to 4 and 1. On the outside, we'll have 1x. On the inside, 24x. So no, that's not going to make 5. All right, so we know 1 and 4 doesn't work. So we move on to 2 and 2. Put 2 here, 2 here. On the outside, we get 2x. On the inside, we get 12x. Is that going to make the minus 5x that we need? No, it's not. Luckily, both those numbers are the same, so we don't need to switch them around. And we see that it doesn't work for 2 and 2. It means we were wrong in the beginning with the 1 and 6. So we got to go back to the drawing board. The 1 and the 6 were wrong. So use 2 and 3. 2x and 3x. And go through our list over here again. Starting with 1 and 4. On the outsides, we got 8. On the insides, or 8x. And on the inside, since that's an x, we have 3x. Can we make negative 5x out of that? Yes, we can if we subtract. All right, we're going to need plus 3 and minus 8 to make a negative 5, which means the plus 3 means 1 has to be positive, and on the outsides, the negative to get negative 8x, 2 times negative 4. So there's our answer. 2x plus 1 times 3x minus 4. Now, the thing about factoring quadratics is it's a skill you got to practice a little bit, all right? You got to do a million of them to get really good at it. But once you start doing a handful of them, you start to get the feel of how they're going to work themselves out, you know, and that's the only way you can get good at them. So please do the homework, ask questions, keep practicing. That's how you'll get good at it.